Good day, viewers. You are welcome back to Tindanious Maths and Science tutorials. We are still under the business. We are treating transformation of functions. We have already set the ball rolling where we're able to figure out for our own selves some mathematical concepts behind transformation of function. So if you are new here, kindly visit my previous lectures where I have dealt with the introduction. Alright, so let's consider the graphical approach to the function. Functions is not all about you solving for a certain variable. But when we talk about function can well be explained using graph. So that is what the geometric definition of functions, alright? So when I have, let's say, a quadratic function, okay, so just let me use, permit me to use y is equal to x squared, alright, okay. How would you draw this? Or what is the nature of this? Y equals x squared. So we have to what? We have to show this geometrically, okay? So again, considering our rectangular coordinate system, okay? So we have my y-axis here, I have my x-axis here. So to graph this, y equals x squared is simply a parabolic curve, okay? So a parabola. So I have this way, pass to the origin, then this way, alright? So we start from this way, at point in time, decreasing, it gets to the origin, then it's what? It increases. So this is what? The graph y equals x what? Squared. Alright. Now, when I add certain units or magnitude to this, again, that calls for transformation. Okay. So we have the original function and we've done something to the original function, changing its form. That is what we mean by what? Transformation of functions. So if I have y equals x squared, then plus 3. Or let's say plus 5. Any magnitude at all. How do I graph this? You don't have to memorize any stuff. It's just simple. So remember, whenever you have a function of say f of x plus a certain unit of say, let's say 2, we have already explained this in our first lecture slides, okay, where we got to understand the interpretation of this. So this includes what? Vertical upwards, okay, this way. Vertical upwards by a magnitude of what? Of 20. And you realize we have something like this. But this time around, this has what? An exponent of 2. Okay, you have to use the same concept. So the positive 5 implies that you what? You graph it, then you shift the graph what? Vertically upwards by a unit of what? Of 5. So giving y equals s squared, we know that this will be the graph. So let's graph this. Y is equal to s squared plus 5. The same analogy, okay? So we know that x squared will give you this form, and the positive 5 implies we are going to transform, or we are going to what? Move this graph or the curve vertically upwards by a unit of what? Of 5, alright? So how do we do that? So we just do this because it has to do with vertical. So we consider the top part of what? Of the xy plane, okay? So if let's say this is 0, this is 1, this is 2, this is 3, 4, and all the way to, let's say, 5. This way. So this will be shifted, okay, to move from the origin, which is what? 0,02. A unit of what? Of 5. So I will shift this from the origin up to the 5. So the assumed curve becomes this. Do you get it that way? So this is what? Y is equal to x squared plus what? Plus 5. So this is how it is done. So this is my y. So viewers, let's show this geometrically. Okay, let's grab this. So how do you do that? Negative 3. What does it imply? Vertical what? Downwards, okay? Vertical downwards. By a unit of what? Of 3. So I have it this way. You know that x squared takes this form, but this time I have negative 3. Okay. So that means I'll move what? I'll shift this what? Downwards by a unit of 3. So let me assume this is my negative 1, negative 2, and my negative what? 3. This way. So this becomes see it has been shifted. So here it becomes this way. So this is the graph of what? Y equals x squared minus 3. Have you seen the essence of the first lecture slides? If you are new here, kindly visit the previous lectures. Okay, for more understanding. Now let's consider the absolute given function. Okay, the absolute given function. Y equals x. The absolute of x is given by this, right? So y is equal to the absolute value of x. So the graph of this becomes, you have your xy plane. Then it becomes something like this. Something like this. To the origin. Then away from the origin. So this is the name of the graph. Y is equal to the absolute value of what? Of x. Alright? Okay, so what happens if plus 2 is added? Okay, so you are trying to transform what? The graph. So using the same analogy, alright? So this simply means what? Vertical what? Upwards by 2 units, alright? Okay, so to do this, we know that the graph for the absolute value, okay, given function here is the absolute value of x. The graph is this way. This way, and plus 2 vertical what? Upwards by a unit of 2. So we are going to shift this to what? To the top part of my xy graph, since it is what? Vertical. Alright, so if this is 0 and this is, let's say, 1, let's say this is 2, so we are going to shift this to 2, okay, by a unit of 2. You have it this way, then you just draw this way, and this graph becomes what? Your x, your y is equal to the absolute value of x plus what? Plus your 2, as simple as that. So to explain functions very, very well, you have to understand what? The geometric definition. So we use graph to interpret functions. let's change there to -2. So negative tells us that what? We are moving what? Downward by a unit of what? Of 2, or by 2 units. So this becomes, let's y, because the absolute value of x minus. Viewers, this is the end of the lesson. So far as this YouTube channel is concerned, we are going to learn a lot. Keep safe and blessed. Remember to subscribe, share, like and comment for more interesting topics and videos. See you next time. Bye.